Hello students, now we will discuss about Tossim. Course outcome. On completion, students will be able to understand the Tossim architecture. Tossim architecture. Tossim is a dedicated simulator for tiny OS applications running one or more Berkeley modes. To achieve these goals, Tossim takes a cross-compilation approach that compiles the next source code into components in the simulation. The event-driven execution model of TinyOS greatly simplifies the design of Tossim. By replacing a few low-level components such as the ADC, the system clock, and the radio front end, Tossim translates hardware interrupts into discrete event simulator events. This is the Tossim architecture. The simulator event queue delivers the interrupts that drive the execution of a node. The upper layer TinyOS code runs unchanged. Tossim uses a simple but powerful abstraction to model a wireless network. A network is a directed graph where each vertex is a sensor node and each directed edge has a bit error rate. Each node has a private piece of state representing that it hears on the radio channel. If a bit error occurs, the simulator flips the bit. Tossim has a visualization package called TinyVis, which is a Java application that can connect to Tossim simulations. Physical environment model. A key element of the environment within which a sensor network operates is the physical phenomenon of interest. The environment can also be simulated at the various levels of detail. If the nodes are mobile, then the positions and motion properties of the nodes need to be modeled. For example, a moving object in the physical world must be abstracted into a point of signal source. The motion of the point signal source may be modeled by different equations or interpolated from a trajectory profile. If in addition to sensing, the network also performs actions that influence the behavior of the environment, then a more tightly integrated simulation mechanism is required. Statistics and visualization. Since the goal of a simulation is typically to derive global properties from the execution of individual nodes, visualizing global behaviors is extremely important. A sensor network simulator simulates the behavior of a subset of the sensor nodes with respect to time. Depending on how the time is advanced in the simulation, there are two types of execution models: cycle-driven simulation and discrete event simulation. Thank you.